Hello and welcome back. In 11.4 we get to work with tree diagrams. So first we need to get a little vocab out of the way. If we have a list of all possible outcomes of an experiment, that is a sample space. So for example, flip a coin twice. If that is our experiment on our sample space, we land on heads, heads, heads then tails, tails then heads, tails then tails. There's 4 ways that that experiment could come to an end, so that is our sample space. I also want to know the counting principle. So we have 2 different experiments. Experiment 1 can end m different ways, 2 can end n different ways. Then the 2 experiments in that order can end in m times n ways. So for example, flip a coin. And select rock, paper, scissors. So if that's our 2-part experiment, then we have 2 times 3, 6 ways to end. And our sample space for this one, we could land on heads, then rock, heads then tails, heads then scissors, tails rock, tails paper, my apologies there. Heads rock, heads paper, heads scissors, tails rock, tails paper, tails scissors. 6 ways for that experiment to end, 6 elements in the sample space. But this section is all about the tree diagram. In the tree diagram, we show each experimental stage and how many ways it can end. So our first part of the experiment was flipping a coin. It can land on either heads or tails. After that, we were selecting either rock, paper, or scissors. So from each of those original outcomes, we could land on rock, paper, or scissors. So we have 6 branches at the end of the experiment. So heads rock, heads paper, heads scissors. So notice this does look like our sample space, just sort of written vertically. Our next little example, though, of a tree diagram gets to selecting things with or without replacement. So we're going to have Amy, Bob, Cal, and Dan. We're going to draw 2 names without replacement. So that will be our experiment. If I want to draw a tree diagram representing that, I might select Amy, I might select Bob, I might select Cal, I might select Dan. Stage 2, I've done this now, again, without replacement. Once Amy's name has been drawn, I throw away the little card that had her name on it. Now I can only select either person B, C, or D. Similarly, if I drew Bob, Bob's out of the running. Now I can only select Amy, Cal, or Dan. If I select Calvin first, then I'm down to Amy, or Bob, or Dan. Similarly, if Dan's the first, land on A, B, or C next. So watch for those experiments where they specify with or without replacement. If it's without replacement, once you've picked that on the first round, it cannot happen in the second round off of that same branch. We have AB, AC, AD, BA, BC, BD, and so on. And we can then work with this. We can solve some probability problems with these trees. So for example, we'll find the probability Amy is selected. So probability of Amy. So it's 1, 2, 3, 4, 5, 6. Out of 4 by 3, 12 events, or 1/2. But if I want the probability Amy selected, then Dan is selected. There I've specified an order: Amy, then Dan. There's only one way for that to happen out of the 12 outcomes. All right, so I'm going to give you all a 3-part experiment. So you're going to randomly select an integer, 1 through 3 inclusive, as stage 1. Stage 2, randomly select a 2 or a 3. And you're going to finish it out by flipping a coin. start with your tree diagram and unpause it. Okay, welcome back. So this one, a 3-stage experiment. So we're going to have 3 sort of branch off points. So the first one, select integers from 1 through 3 inclusive. So 1, 2, or 3. Second stage, randomly select an integer, this time only from 2 to 3. And then we flip a coin. So each one of these can end on either a heads or a tail. So our sample space, 1, 2, then heads, 1, 2, then tails, 1, 3 heads, 1, 3 tails, 2, 2 heads, 2, 2 tails, 2, 3 heads, 2, 3 tails, and so on. Okay, so this is our tree diagram. We also have now our sample space. This one is written vertically. And now that we have our sample space, we'll look at some probabilities. Selecting both a 1 and a T. And when you figure that one out, probability at least 1, 2 is selected. So go ahead and pause that, see if you can figure those out. Unpause it when you're done. So our first one, probability of having both a 1 and a tails involved. I'll do these in red. So this has a 1 and a tail, this has a 1 and a tail, nothing else has a 1. So probability 1 and a tail involved. There were 2 of those outcomes. Number of ways our experiment could end. 3 times 2 times 2, 12 ways. 2 12s, our probability simplifies to 1/6. Second part, probability at least 1 of the 2's selected. I'll do this one in, I guess, blue. So this guy has a 2, this guy has a 2, this guy has a couple 2's, this guy has a 2, this guy has a 2. Plenty that had 2. So 1, 2, 3, 4, 5, 6, 7, 8 of those selected. 8 12s and factor of 4 top and bottom, so 2/3 is our probability of selecting at least one thing that has a 2 involved. Probability of no 2's, again, this is continued from the previous page. No 2's selected, 4 out of 12, that will simplify down to 1/3. Now sometimes it is easier to look at the probability of selecting none of something and use that to find the probability of at least 1. So a note on here, probability at least one of the 2's. 1 minus the probability of no 2's. So 1 minus 1/3 is the 2/3 that we saw on the previous page. So this one, it wasn't too hard to count either one of them, but there are many times where finding the probability of something not happening is fairly straightforward, and finding the probability of at least one of something covers hundreds or thousands of cases. This is a handy thing to have. So the sort of the general form, probability that happens at least once. One minus the probability event does not happen. Now, all of the trees so far have dealt with equally likely outcomes in each case. Later on, we will start looking at things like selecting a face card or not a face card when we draw a card. In that case, instead of just the blank trees, we will start attaching numbers to the branches. So probability excuse me, of a face card, recall, is 3/13. Probability not a face card, 10/13. So later on, we will start attaching numbers to these things. There's a little bit we need to learn before we do that, but this is sort of a sneak preview, just letting you know that we're not yet done with tree diagrams. Okay, so some problems to try out. This is 11-4. I'll try 1 through 4 all, and 5 to 27 on the odds. If you have any questions, of course, please get in touch. Otherwise, I'll see you next time. Stay safe out there.